Good morning.
Morning.
Good morning.
How are you guys? Are you okay?
Yeah.
Okay. Let me remind you our last time topic. We were studying trigonometric equations. I will continue working with equations, and if I have time today, I will start trigonometric identities. But let me show you the last problem. I hope it is problem number 13 from page 206. Is it?
Yeah.
Yes.
So thank you. Thank you very much. So I would like to ask you to open your site, or if you have actually a book, open this material on page 206, because on pages 206 and 207 we have quite many equations, and I randomly will solve these equations. Okay. If any problem catches your attention, also please feel free to ask me to work with that particular problem. Is it?
Can we do question 18?
What did you say?
Question 18.
Yeah, definitely we can. So 18. Again, please read again the request which we have for all these problems. Solve each equation on the interval, and I really recommend you to write this down each time when you copy every equation which you need to work with. So in problem number 18, we have tangent of theta over 2, which is equal to square root of 3. This is quite short equation. Put comma, and you can write this interval in two different forms. You can write this in exactly the same way as double-sided inequality. Or in slightly more modern form. Looks visually different, but it is same semi-closed or semi-open interval, because I purposely made that ends quite thick to show you what I have. You can see one end at 0 has a bracket. It means it is a closed end. 0 is included in that interval, but 2 pi, you have round parentheses, which means that end, which is 2 pi, is excluded. So practically it is one revolution, but one revolution usually from 0 to 2 pi, including both ends. So practically only one end is excluded, but as you know, 0 and 2 pi on the circle, they have same end point. Okay. Now, can you please remind me if tangent in general is pi periodic function or 2 pi periodic function?
Pi periodic.
Pi periodic. Now, I again recommend you to work with the unit trigonometric circle, trying to make this process more visual. So don't sketch really big ones. Some decent size of the circle, it can be quite small. And look what we are going to do. I'm going to sketch that circle and I will show it to you. It is my, excuse me, alarm. Okay. I'm not using any, this is why my circle probably will be not perfect. This is my unit trigonometric circle. And now listen carefully. Unfortunately, book is not showing this line, but I will show you that line. Let's recall definitions of trigonometric functions. And again, I'm using here a unit trigonometric circle. In the unit trigonometric circle, sine of any angle is equal to y coordinate of the endpoint on the terminal side, right? Cosine is equal to x coordinate of the endpoint on the terminal side. But how can we find geometrically, how can we find the tangent value or cotangent value using the circle? And I'm saying how we can find geometrically. Yeah, definitely. Tangent is the ratio of y coordinate over x coordinate for any circle, unit trigonometric or not. We operate for that purpose to find geometrically the value of the tangent. We operate with so-called tangent line. Tangent line is the line which is touching the circle at the point which is, can you see that endpoint on the terminal side for 0 degrees?
Yes.
This is so-called tangent line. So if you need to talk about cotangent line for another problem, let me on the side show that also. Because this will be the easiest way to solve these problems. Another circle. So please, next to that line, write down that it is a tangent line, so you will not forget about the, you will not forget the name of that line. This is line of tangents. It is a tangent line. Now, another line which we also use in trigonometry is a line of cotangents. Line of cotangents. This is the line which touches the circle on the top, touching that circle at the point which is the terminal, which is the end point on the terminal side for 90 degrees angle. Do you understand the difference? Line of tangents,
Yes.
on the left, line of cotangents on the right. But we don't need right now cotangent line, maybe for future problems. This is why just I'm boxing this, just saying that this is for another problem. Let's concentrate on this one. Is a tangent of theta over 2 equal to square root of 3?
Yes.
Square root of 3 is a positive number.
Yes.
Yes. What is approximate value? You can use even calculator to estimate. I can tell you about that. I remember the value. Can you check, please, on your calculators?
1.73.
Is that roughly about 1.7?
Yes.
Excellent. 1.7, is it greater than 1?
Yes.
Oh, and look what we are going to do. Do you remember we used trigonometric circle?
Mm-hmm.
So we use radius is 1, right? So
Yeah.
1.7, it is not 2 times greater, but at least more than 1.5 times greater, and it is a positive number. So look what I'm going to do. I will show a dot on that line. Can you see the dot?
No. Yes.
Yeah.
Yeah, that thick dot on the tangent line. This is, let's say, the number, because if I count, if I say that at this point, right here, tangent is equal to 0, because it is an intersection with x-axis. Can you see?
Mm-hmm.
Above, we have positive numbers. Below, we have negative numbers. So 1.7, let's say it is that point, because I'm not looking for exact, you know what location, approximately. And it is higher than 1, because if I sketch perpendicular, 1 will be at some place right here. So it is above that 1. Connect, please connect that dot with the center of the circle. And continue until you reach another side of the circle. Did you do that?
Yes.
Right? Guys?
Yeah.
Yeah.
And look, right now here, we can show 2 angles which have tangent equal to square root of 3. I'm going to use arcs to show that angles, which we can find very easily. These are 2 angles in that particular circle which have tangent equal to square root of 3, because you can actually next to that dot write square root of 3. Square root of 3. I don't know if you can see. Can you see I wrote square root of 3? And let's now find these angles. But don't forget, in our problem, our angle was theta over 2. Theta over 2. Okay. First option, theta over 2 equals which angle in the first quadrant has tangent equal to square root of 3? Guys, this is the material.
Pi over 3.
Which angle in the first quadrant, in other words, arctangent of square root of 3, which angle has tangent equal to square root of 3?
Pi over 3.
Pi over 3. So write down pi over 3. This is part A. But I'm not looking for theta over 2. Do we look for theta angle? Guys, this is theta over 2. To solve that equation, I need to find the value of theta. Should I multiply both sides by 2?
Yes.
Okay. I'm multiplying by 2, and I'm getting theta equals 2 pi over 3. 2 pi over 3. Is it in that revolution? Don't forget, pi over 3 is 60 degrees equivalent times 2, 120. Is it our solution?
Yes.
Yes, you can box it. This is already our solution. Now I am going to now. Excuse me, can you please make it silent? Yeah, I know. I also can be victim of these calls. Now, I am going to find right now the second angle. The second angle, is it in the third quadrant?
Yep.
Do we know that in the third quadrant, tangents are also positive? Yes. But
Yes.
what about this other angle, which is again theta over 2? Theta over 2. Can I say that this new angle, which is in the third quadrant, equals to the small one plus pi, or pi plus that angle?
Yes.
So write it down. Pi plus pi over 3. And this is for theta over 2. So which means theta over 2 equals 1 pi plus pi over 3, which will be 3 pi over 3 plus pi over 3 is 4 pi over 3. But this is theta over 2, and I'm looking for theta. I will multiply both sides by 2 again. So in this case, if I am multiplying both sides by 2, I am getting second theta, which is 8 pi over 3. And now we need to check again if it is our solution or not. Again, pi over 3 is equivalent of 60 degrees. If you multiply 60 degrees by 8, you are getting 480 degrees. Is it in that declared interval?
No.
Right. Our interval was from 0 to 2 pi. 2 pi, is it equivalent of 360 degrees?
Yes.
But we got an angle which is 480 degrees. Is it in that interval?
No.
No, which means it is not our solution. If we need to find all possible solutions without having that interval, just in general, all solutions in set R, we are going to have infinitely many answers because tangent is pi periodic function. But here we are limited by that particular interval. And because of that, in our solution set, we have only one angle, which is 2 pi over 3. We found that angle, and it was the only angle which we had in that particular interval. So that's it. This equation has one solution. I'm done with this problem. Questions?
No.
Okay. Let's solve another problem. Again, if something catches your attention, please be vocal. What about problem number 27? Are you okay with problem number 27?
Yes.
Okay, please copy the problem. While you do that, I will quickly check attendance. 1 second. Bryce?
Here.
Gracia?
Here.
Alexia?
Here.
Okay. Hannah?
Here.
Andrew? Dimitar?
Here.
Benjamin? Jesus?
Here.
Ariana?
Here.
Axel?
Here.
Desiree?
Oops, here.
Lila,
Here.
Bhaktima,
Here.
Jessica,
Here.
Ivuna,
Here.
Devin,
Here.
Valeria.
Here.
Excellent. And now let's see what we have in this particular problem. We have another function, which is secants. 4 secants theta plus 6 equals negative 2, comma, theta belongs to semi-closed interval from 0 to 2 pi. I am going to solve first for secants theta, and after that, I will start looking for theta. What do we have here? Secants theta has here 4 as a coefficient. It has 6 as a free term on the left side and negative 2 on the right. Can we move that 6 to the right, changing its sign?
Yes.
Is it going to be negative 6 minus 2?
Yes.
In other words, is it 4 secants of theta equal to negative 8?
Yes.
Can we divide both sides by 2? Yes, we can. But what would be in our benefits? To divide both sides by 2 or by 4?
By
By
4.
4.
Definitely by 4. Divide by 4. And what do you get after dividing by 4?
Secant theta equals negative 2.
Perfect. Absolutely. Yes. So secant theta equals negative 2. I definitely can right now immediately start looking for theta, for which secant is equal to negative 2. Excellent. But if you had a choice to choose between secants, which is one of trigonometric functions, 6 trigonometric functions, or cosine, which one would you choose?
Cosine.
Me too. Because it is much easier to deal with cosine than with secants. But why did I choose, let's say, cosine to start talking about cosine when I had secants? Do we have any connection in between? I'm talking about cosine and secants. Do they have close relationship or not?
They
They're
do.
reciprocal.
They are reciprocals. I heard what you said. They are. So if secant theta is negative 2, what would be the value of its reciprocal?
Negative 1/2.
Absolutely correct. So it is your right to remove secants from the scene and to replace it by cosine, because it is the same angle. It is angle theta for which secant is equal to negative 2, which means its cosine is equal to negative 1/2. So far, so good?
Yes.
And now, let's sketch again that small circle to see what is going on here. Don't forget, cosine is equal to the negative number. Cosine is negative in which quadrants?
Second and third.
Second.
Yes. Do you remember we used a unit trigonometric circle?
Mm-hmm.
1/2 negative. Do you remember it should be equal to the x coordinate, right?
Mm-hmm.
Look where I found the location for negative 1/2, right in the middle of that radius on the left side from 0. Is it negative 1/2?
Yeah.
For x. Restore perpendicular until you cross circles in all possible points. I sketched a perpendicular and continued it until it crosses the circle in 2 points. So far, so good?
Yeah.
Connect these points on the circle with the center. Connect this with the center. And you already can see two angles which have that cosine equal to -1/2. One angle is in the second quadrant, one angle is in the third quadrant, as we just talked about, because in the second quadrant and in the third quadrant, cosine is negative. And now let's actually find these answers. Let's first start with the angle in the second quadrant. So theta 1. Ladies and gentlemen, which angle in the first quadrant has cosine equal to +1/2?
Pi over 3.
Pi over 3. Can I say that this angle in the second quadrant is equal to pi minus pi over 3?
Yes.
So write it down. Pi minus pi over 3. 1 pi minus pi over 3 will be 2 pi over 3. And as we already discussed, it is equivalent of 120 degrees. Is it in our declared interval from 0 to 2 pi?
Yes.
Box it. This is your answer. Let's now talk about another angle, which is in the third quadrant. Can I say that this other angle is pi plus pi over 3?
Yes.
Yeah.
Write it down. If you add pi and pi over plus pi over 3, you are getting 4 pi over 3. 4 pi over 3. Pi over 3 is 60 degrees equivalent times 4, 240 degrees. Is it in our interval?
Yes.
Box it. We found the value of the second angle. Do we have more angles?
No.
No. In the declared interval, no. If we need to talk about set R, it will be 2 pi over 3 plus 2 pi k, because cosine is 2 pi periodic, and 4 pi over 3 also plus 2 pi times k. But here we are done. So we can write solution set. Solution set has two answers. 2 pi over 3, comma, 4 pi over 3. That's it. This is your final stage in this problem. Solution set has two solutions, two answers. 2 pi over 3, 4 pi over 3. And we are done with this problem. Did you understand the process?
Yes.
Yes.
But again, working with these problems, you need to be equipped by values of trigonometric functions from that tables which we covered long time ago, You need to know which functions are pi periodic, which functions are 2 pi periodic. You need to know definitions of these trigonometric functions, and you need to be quite good friend with algebra. So you can understand, definitely, you need to know quite many things to work with these problems. I want to show you right now problems which can look slightly different. And I'm talking about problems 31, 32, 33, 34. Are you okay if I start working with problem number 32?
Yes.
Okay. I need to grab another piece of paper. Are you okay if I remove it?
Yes.
Yes.
Okay. Again, page 206. I hope that today's lecture will be recorded properly on Zoom because, oh my God, I was under such a horrible stress last time. Entire day I tried to reanimate. Zoom did not record it. Instead of recording this separately, it's recorded twice, lectures from pre-calculus class replacing your lecture. I don't know why. I did not have control over that. So number 32 has sine parenthesis 3 theta plus pi over 18 close parenthesis equal to 1. Put comma and then write that theta belongs to semi-closed interval from 0 to 2 pi. God bless you guys.
Bless you.
Okay, can you please now tell me about a difference between this problem and what we solved before? Do you see any usual difference in original problems?
There's a pi.
Not only, is it the angle under symbol of sine, which looks much more complicated than what we had before?
Oh,
Yes.
yes.
This is what I'm talking about. Here, it looks much more complicated because it is 3 theta plus pi over 18, blah, blah, blah. So let me give you my recommendation. When you have problems with quite complicated angles under symbols of trigonometric functions, try to use more general approach to the problem. Don't forget your angle here originally is 3 theta plus pi over 18. It is sine of 3 theta plus pi over 18 equal to 1. And don't forget that our sine as a function is a 2 pi periodic. Do you remember that?
Yes.
Excellent. Look what I'm going to do. First of all, which angle in one revolution has sine equal to 1?
Pi over 2.
Is it maximum for that sine in that particular circle, right?
Yes.
So let's sketch, again, small circle, and let's show that angle. Is it what you talked about?
Yes.
Excellent. Let's write down 3 theta plus pi over 18, this was our angle, equals pi over 2. But now I will adjust what I just wrote down. Instead of just pi over 2, I would write pi over 2. You can see I wrote plus. And do you remember I just talked about that it should be actually, we should remember that sign is 2 pi periodic function.
Mm-hmm.
So I'm going to write 2 pi, but not only, I am going to write 2 pi k. What about this k? K tells me about how many times I will be rotating with 2 pi. K can be positive integer, it can be negative integer, and it can be equal to 0. So which means it belongs to set Z, capital Z. Capital Z. So it is 3 theta plus pi over 18 equals pi over 2 plus 2 pi k. And ladies and gentlemen, I all the time recommend you, if in your problem you have not a simple angle like theta, let's say you have, let's say 3 theta, 5 theta, 22 thetas plus or minus pi over something, please use that approach. Use information about their periods. So but what about that set Z? I'm going to remind you at the beginning when we were reviewing algebra, I reminded you about this set because this set will be playing tremendously important role in trigonometry. Just 1 second, I will show it to you because I'm writing this in my notes. This is that set where we have only integers. This is the set of all integers. You can see it is also double-legged capital Z. And now, look what I'm going to do. I am going to solve this equation for theta. Theta here comes with 3 as a coefficient, with pi over 18 as an add-on. So what I am going to do, can we first move pi over 18 to the other side?
Yeah.
Let's do that. So it will be 3 theta equals negative pi over 18 plus pi over 2 plus 2 pi k. If you have 18 in denominator and 2 in denominator, what would be your LCD?
18.
Right? So it will be negative pi over 18, and I'm going to convert pi over 2. So is it 9 pi over 18?
Yes.
This is like you will work with a regular algebraic problem. If you add these two, negative pi over 18 and positive 9 pi over 18, is it 8 pi over 18?
Yeah.
8 pi over 18. Excellent. Now, dear guys, if you have fraction which has 8 pi on the top, 18 in the denominator, okay? What would you do? Can we cancel by 2?
Yes.
So it will be 4 pi over 9, right?
Mm-hmm.
So can you see right now, I stopped actually working with trigonometry. I am using algebra. This what we did, simplifying that addition of 2 fractions. But I am not interested in the 3 theta value. What would you do to get theta?
Divide by 3.
Can we divide by 3? Yes. Can we multiply by 1/3?
Yes.
You know what? Definitely we can divide both sides by 3, but because I see here on the right side, I see a fraction, I prefer probably to multiply by 1/3. So I'm going to multiply both sides by 1/3 because multiplication by 1/3 or division by 3 mathematically will give me same result. Can you see what I did? Now I'm going to finish that. 1/3 times 3 is theta. 1/3 times 4 pi over 9 will be 4 pi over 27. 2 pi k times 1/3 will be 2 pi over 3 times k. Agree? Disagree?
I agree.
Just one person?
I agree.
Agree. And now, guys, we are going to play with values of k because we need to choose values which belong to declared interval from 0 to 2 pi. Okay, I'm going to start with the nicest value. K is equal to 0. K is equal to 0. Plug it into your expression for theta. Theta 1 will be equal to what number? Is it 4 pi over 27?
Yes.
So write it down. Grab your calculators. And the easiest way is to deal, let's say, instead of pi with 180 degrees. So it will be even easier. So do what? Multiply 4 by, in parentheses, 4 times 180, close parenthesis, and divide by 27.
26.7 degrees.
And you are getting 26 point and so many 666 and etc. This is about 27 degrees. Is it in our interval?
Yes.
That's it. It is your answer. Next, let's say I'm going to have k is equal to 1. And I'm going to plug this into my expression for theta. So it will be theta 2. It will be 4 pi over 27 plus 2 pi over 3 times 1. And it will be 2 pi over 3. What would be LCD for 27 and 3?
27.
Right? So which means I will convert the second fraction into a new one, multiplying top and bottom by 9. Is it correct?
Yes.
So what do you get here?
4 pi over 27 plus 18 pi.
Absolutely, yes. Add them. What do you get? Is it 22 pi over 27?
Yes.
Yes.
Let's check if it is our answer or not. Do the same thing. Parenthesis, 22 times 180, close parenthesis, and divide by 27. And what did you get?
146.
Is it about 147?
Yes.
Is it our solution?
Yes.
Box it. Can you see we got the second one? I'm going to move to another one. K is equal to 2. It will be already the third value. So it will be 4 pi over 27 plus 2 pi over 3 times 2. Is it 4 pi over 3? guys?
Yeah.
Let's change denominators again because we are looking for LCD. So I am not changing the first one, but the second one I will change, having 27 downstairs. Should I multiply top by 9?
Yes.
If you multiply 4 by 9, what do you get?
36.
Right. So you are getting 4 pi over 27 plus 36 over 27. Add this, what do you get? I am waiting, guys, for your reply. If you add 4 pi over 27,
You get 45.
40 pi over 27. In the same manner, check if it is our answer or not. Grab your calculator and do the same thing. Now, parenthesis, it will be 40 times 180, close parenthesis, divided by 27. And I got about 267 degrees. Is it our solution?
Yes.
Box it. I am moving to the other one. K equal to, you can use negative numbers also, but at least if everything new works and works, it is additional answer. You need to work until you see something which is out of that interval. So I used K equal to 3. So it is already theta number 4 value. So it will be 4 pi over 27 plus 2 pi over 3 times 3. Is it just 2 pi?
Yes.
Okay. And 2 pi, is it 360 degrees?
Yes.
If you add, and look what I'm doing. I'm writing this right, I'm entering this right into my calculator. 360 plus 4 pi, so it will be in parentheses, 4 pi, which is 4 times 180, close parentheses, divided by 27. And look what I got. I got about 387 degrees. Is it our solution in that interval?
No.
So don't box, don't continue, just stop right here. I even do not want to continue to find the form for this angle. I'm stopping here, and now I'm going to write solution set. Solution set is having 4 pi over 27, comma, 22 pi over 27, comma, 40 pi over 27. We got solution set which has 3 angles. And we are done with this problem. Did you understand the process?
Yes.
Let's summarize what we had. We can have quite easy angles in the problem. In this case, we can use shortcut without thinking about periods of declared functions. If in your problem, in your equation, you have quite complicated angles under symbols of trigonometric functions, you need to use that long way to solve the problem, finding the family of all possible solutions. I'm going to box that family. This is the family of all solutions, family of all solutions for that particular equation. But from the beginning, we were limited. We had only one revolution. It was an interval from 0 to 2 pi. This why we start playing with k value to find that particular answers, which are from the interval from 0 to 2 pi. And we discovered that from one revolution, we have three answers, three angles which satisfy that equation. Is it clear?
Yes.
So we have two approaches. Again, one approach, when angles are quite easy, we can use shortcut, just having the circle, finding the location of these angles, writing down the answers. If we have more complicated case, we are looking for the family of all possible solutions. And after that, playing with parameter k in this formula, we are calculating specific angles which can fit that particular interval which was declared in our problem. I am declaring right now 5 minutes, maybe slightly a little bit bigger interval for rest. No, actually 5 minutes. And after that, we will continue. Please be back at 11:10. Is it okay with you?
Yes.
Yes.
And we will solve more problems. I hope you are back. Are you?
Yes.
I'm back. Yep.
Yes.
Can you please look at problem number 40 and copy that on your paper and read what is requested here? Look what I wrote. I wrote sine theta equals square root of 2 over 2. I did not write anything about theta, that theta is from certain interval. It is just separately standing alone equation, which is sine theta equals to square root of 2 over 2. And what do we have here? I'm going to read. Solve each equation, give a general formula for all the solutions. Give a general formula for all the solutions. List 6 solutions. This is very important because they are asking us to find a family of all possible solutions for that equation. If you remember, I boxed this expression for theta, and this in the box, this what we had. This is the general formula for all the solutions of that equations. And using that general formula, I was able to choose that solutions which we were interested in, which we had in the semi-closed interval from 0 to 2 pi. Here, it is a different story. We just need to solve it generally, finding the formula which represents the entire family of all possible answers. And after that, they ask us to list just 6 of solutions. It will be up to you which solutions to list. So let's start solving this problem. Can you see that sine symbol has theta next to that?
Yes.
Is it quite simple angle?
Yes.
But even though it is quite simple angle, and I could use a shortcut as we used in many problems when we had declared interval, here I cannot do that because, again, this particular request here to find a family of all solutions. This is why, even though I can sketch that circle which I had before, what about that value, square root of 2 over 2? Square root of 2 is approximately, roughly 1.4. 1.4 divided by 2 is, again, a rough answer for this square root of 2 over 2 will be 0.7. Is it a positive number?
Mm-hmm.
Is it affiliated with y coordinate in the unit trigonometric circle? It is equal to y coordinate.
Yes.
Maximum value is 1. So which means 0.7 will be a dot quite close to 1
Mm-hmm.
for y. Can you see? It is above the middle point. What should I do next? I am going to sketch perpendicular as we did before, and I am immediately seeing 2 points on the circle, and I'm going to connect with the center. And I will show right now these 2 angles with arcs, but these are angles only in 1 revolution.
I can't see.
Can you now?
Mm-hmm.
What about others? Guys? Hello? Can I continue?
Yeah.
And now I am going to show two families of solutions. Each will be related to one of these angles. You can see in your circle, you have two angles. One is in the first quadrant, the second is in the second quadrant. Let's start with part A. It is about that angle in the first quadrant. Which angle in the first quadrant has sine equal to square root of 2 over 2?
Pi over 4.
Write down pi over 4, but please don't stop. It is that angle, but we rotate and rotate and rotate coming back to that point on the terminal side. I'm talking about this point, which is right here.
Mm-hmm.
So how can I write this on my paper? So it will be theta equals to pi over 4 plus, what is the period for sine?
2 pi k.
Yeah, can you see what I wrote? Plus 2 pi k. At least once in this problem, right? K belongs to set z. Don't write anymore what this z is equal to. Just write down that K belongs to Z. Voila, this is your first family, and it is already solved for theta. You don't need to simplify this anymore. Let's move to part B and to write something similar for the second family. Can you see? It is the angle from the second quadrant.
Yep.
Mm-hmm.
Okay, what do we have here? Theta equals, is it that angle which we can describe like pi minus pi over 4?
Yes.
Is it again plus 2 pi k?
Yes.
Yes, but I need to simplify because I need to subtract pi over 4 from pi. So, which means there will be theta equals pi minus pi over 4 is 3 pi over 4. And voila, this is the second formula. So we have two formulas for members of the family of all answers for this particular equation. And now we are going to move to the second stage. We need to list 6 answers. Are you ready?
Mm-hmm.
Let's start with, let's say, k equal to 0. Plug into both families. What do you have? Theta 1, is it pi over 4?
Yes.
From the second family. Theta 2, is it 3 pi over 4?
Yep.
And honestly, both are from first quadrant, but we are not limited here. They are asking us just to list 6 answers, and we have already 2. Theta 1 and theta 2. So I'm not checking if they belong to certain interval or not, I don't mind. K is equal to 1. If you like, you can use -1 as well. It is up to you. But probably I would go for positive because they do not have specifics here. So plug K equal to 1 into both formulas, but it will be already theta 3. So it will be pi over 4 plus 2 pi times 1, which is just 2 pi. Can you give me the answer? LCD is 4. What did you get, guys? Pi over 4 plus 2 pi. What did you get as an answer? Ladies and gentlemen, I'm waiting for your reply.
9 pi over 4.
Accepted. Yes, definitely. Plug it into second formula. Now you will have 3 pi over 4 plus 2 pi, and give me the answer, please. What did you get? Adding 3 pi and 3 pi over 4 and 2 pi. Excuse me? Guys, you cannot add easy fractions?
11 pi over 4.
Accepted. I already wrote it down a while ago. I already have 4 values, but I will keep going. And the other one, I will be using, let's say, k equal to 2, plugging again into both formulas. So it will be theta number 5 and theta number 6. So in the first formula, it will be pi over 4 plus 2 pi times 2, which will be 4 pi. In the other family, it will be 3 pi over 4, also plus 4 pi. And please find answers for both. And I'm waiting for your answers. From the first family, when k is equal to 2, what did you get, guys?
17 pi over 4.
Accepted. For the from the second family?
19 pi over 4.
Yes, and look, I also have absolutely same answers. That's it. They wanted 6 answers from the general family. We provided for values of k equal to 0, 1, and 2. That's it. We are done. I am going to solve another problem from this spot, and this is problem number 44. 44. Please copy that, and we need to solve it in the same manner. Don't forget, it is tangent. Look what I immediately did. Can you see that line touching that circle?
Mm-hmm.
Is it our tangent line
Yes.
or line of tangents? Is it tangent of theta over 2 equal to -1?
Yes.
Radius is of that circle is 1. So basically, -1 is right here below x-axis. Can you see where I wrote down -1?
Yes.
And now connect this point, the center of the circle, and here, even in one circle, you see 2 angles. One is in the second quadrant, another is in the fourth quadrant. And this is nice and very visual, because we know that in the second quadrant as well as in the fourth quadrant, tangent is negative, right? So we actually made it visual, connecting our point on tangent line with the center of the circle and showing this. But be careful, this is theta over 2. So write it down, theta over 2. what would be the first angle? Is it pi minus pi over 4? Why do you talk about pi over 4? Because what about opposite for -1? Is it +1?
Yes.
Which angle has tangent in the first quadrant, the angle from the first quadrant, which has tangent equal to +1? Is it pi over 4?
Yes.
So this why it will be pi minus pi over 4, which is pi minus pi over 4 is 3 pi over 4. But don't forget about period. What is the period for tangent? Is it pi?
Yes.
So this why I wrote pi minus pi over 4 plus pi k. And now you can solve it for theta. So it will be theta over 2 equals 3 pi over 4 plus pi k. Multiply both sides by 2. You are getting theta equals 3 pi over 4 times 2 will be 3 pi over 2 plus 2 pi k. This is your first box, showing the family of all general answers. And now it is part A. Part B is theta over 2 equals, what can I say about this fourth quadrant's angle? Is it 2 pi minus pi over 4? Guys, can I say it is 2 pi minus pi over 4?
Yes.
Don't forget about plus pi k. And do the same thing. Theta over 2 equals 2 pi minus pi over 4. It will be 8 pi minus 1 pi, 7 pi over 4 plus pi k. Multiply both sides by 2, and you are getting theta equals 7 pi over 2 plus 2 pi k. And this is the second formula for theta. And in the same way as we did with the previous problem, I'm going to play with values of k to list solutions. So k is 0. What do I get? I'm getting from the first family, theta 1 equals 3 pi over 2. From the second family, 7 pi over 2. K equals to 1. From the first formula, theta 3 equals 3 pi over 2 plus 2 pi times 1, which is 2 pi. So 3 pi over 2 pi will be 3 pi plus 4 pi. 7 pi over 2, right? But can you see you have 7 pi over 2 the second time? Guys,
Yeah.
so don't count this like another's. If you are getting matching number, please count this just once. So theta 4 equals 7 pi over 2 plus 2 pi. So 7 pi plus 4 pi will be 11 pi over 2. So we already have 3 values. So k is equal, let's say, to -1. Again, because I just don't want to show you all same answers. But if they do not have specific requests that please use only 0 and positive k, it is one thing. It is up to you to use positive or negative, but please start, it is preferable to use, let's say, k equal to 0, you can use k equal to 1, k equal to -1, k is equal to 2, k is equal to -2, etc. So what do you get here? You are getting theta 5, which will be here from the first family, it will be 3 pi over 2 minus 2 pi, because it will be 2 pi times -1. And you are getting 3 pi minus 4 pi, 3 pi minus 4 pi, negative pi over 4. But if you precisely look at negative pi over 4, even though it looks different, and it is actually different angle, it's coinciding with 7 pi. Why did I say over 4? I really apologize. I accidentally, my glasses did not help me. So negative pi over 2. So and keep just going in the same way. And I will let you finish this problem because you actually got how many answers here? 3 pi over 2, 7 pi over 2, 11 pi over 2, negative pi over 2. You have already 4. You just need to get 2 more. Is that clear how to work?
Can I see the solutions? Can you more to the right? Oh, other way, yeah.
Can you see? I showed 3 dots. So which means it is not finished. We need to get 2 more. I do not have space here on the paper. That's why I just say, can you please finish this by yourself? So, but you are just, again, you have in 2 boxes, you have formulas. You are just plugging different k values and use simple calculations to get more and more angles. Is it clear? Can we move to another paper and to another problem? Guys, can I? I did not get your reply.
Yeah.
Yes.
So I'm right now skipping that spot in which we need to use a calculator. I will show that also. I like to move to page 207 because I already showed many examples actually from page 206. And I will randomly show you some of these problems. Let's say it is problem 64 on page 207. 64. Here we can see our interval restriction returns to these problems. I'm going to copy, as we did before, 2 sine squared theta minus sine squared theta plus sine theta is 0, comma, theta belongs to that interval. Cosine squared theta minus sine squared theta plus sine theta equals to 0.
Is this question 64?
Excuse me?
Is this question 64?
Yeah. On page 207. If you have a different edition, it can be a different number. If you precisely look at this problem, you probably can discover that this equation looks different. It looks different than what we had before. First of all, can you see we have different functions here in the same equation. We have cosine and we have sine. Right?
Yes.
Yes.
We did not have it before. We had simple same function, trigonometric function, and that's it. There were some complications with angles, but it was same function, not anymore. And in majority of cases, your equations will look like this one, number 64. So which means you need to ask yourself certain questions to work on this problem. First question is, in this equation, we have 3 spots with trigonometric functions. Do they all carry same angles?
Yes.
Excellent. This is already easifying the process. Question number 2. Do we have same trigonometric functions or they are different?
Different.
Different. So which means you need to use certain trigonometric formulas to simplify the situation. How many spots do we have here with cosine? Is it 1? And it is cosine squared, right?
Yes.
Are there 2 spots here with sine of theta?
Yes.
If I were you, I would try to get rid of cosine squared theta. How? Easily. Do you remember we had a formula which we used systematic cosine squared theta plus sine squared theta equals to 1,
Mm-hmm.
right?
Yeah.
What about cosine squared from this formula? Is it 1 minus sine squared?
Oh. Yeah.
Yes?
Yes.
Mm-hmm.
What it means, I can plug this into my equation instead of cosine squared theta. I can write 1 minus sine squared theta. This is my cosine squared. And after that, I will copy what I had here. Minus sine squared theta plus sine theta equals to 0. And look what happened here. I don't have other functions, just sine theta or sine squared theta. But sine squared theta also has the same function, only in the second power. Do we have like terms here?
Yes.
Yes. So it will be negative 2 sine squared theta plus sine theta plus 1 equals to 0. Does it remind you a quadratic equation like negative 2x squared plus x plus 1 equal to 0?
Yes.
That's it. We can substitute. We can say, asking ourselves, is it a quadratic equation on the last line? No, it is not, because it is a trigonometric equation. Can we say, ask ourselves if it was a quadratic equation with respect to sine theta? Answer will be positive, yes, because the last line is a quadratic equation with respect to sine theta. How can we solve it? We can say, let sine theta be x, and we can substitute h sine, having instead of that x, and look what we are going to get. We are going to get that type of equation. Negative 2x squared plus x plus 1 equal to 0. And after that, we will be solving this as we would solve any quadratic equation. Let's say I'm using quadratic formula. A is negative 2, B is 1, C is 1. And the formula states it is opposite for B plus or minus square root of B squared minus 4AC divided by 2a. I'm reminding you the formula also. And I'm going to plot my numbers. So x is opposite for b, -1, plus or minus square root b squared is 1, minus 4 times -2 times 1 divided by 2 times -2. I plot all my numbers, and now I'm going to simplify. So it will be -1 plus or minus square root 1 plus 8 over -4 -1 plus square root 1 plus 8 over -4. So x equals -1 plus or minus square root of 9 over -4, which is -1 plus or minus 3 over -4. From where? X1 is -1 plus 3 over 4, which is 2/4 over 1/2. Second value, x2 is -1 minus 3 over 4, which is -4. I am going to show it to you right now. I found two x values, but it is not my goal because my original equation did not have x's. Now I need to go back to trigonometry, and I'm going to have part A and part B. Part A.
Shouldn't it be negative 4 at the bottom?
Yeah.
Excuse me, I cannot hear.
Shouldn't it be negative 4 at the bottom?
Yes. I actually thank you very much. I really apologize. Yes, I made a mistake. I accidentally overlooked that one. Yes. So please fix that. Thank you very much. It will be -1/2 and +1. So, and I'm going to write sine theta, which was our x, equal to -1/2. Part B, sine theta equals to +1. So, and I'm going to sketch again because they are quite simple case. X equal to -1/2 is below 0, and I'm sketching perpendicular, and I'm getting two angles. One is in the third quadrant, one is in the fourth quadrant. Again, and now I'm ready again. Find again y equal to -1/2, sketch perpendicular, which can cross circle at point.
Hold it to your right.
Excuse me?
We're not able to see the circle.
Can you see now?
Yes.
And there are two answers, θ1 and θ2. So which angle has sine in the first quadrant equal to +1/2? Is it pi/6?
Yes.
So first angle, which is in the third quadrant, will be pi plus pi/6, which is 6 plus 1 pi, so will be 7 pi/6. And this is 200, equivalent of 210 degrees, so it is our answer for sure. θ2 will be 2 pi minus pi/6, which will be 12 pi minus 1 pi, so it will be 11 pi/6, which is equivalent of 330 degrees, is also our answer. And now I am moving to the second case. Sine equal to 1. Sine equal to 1 is at its maximum. I have here only one answer, which is theta 3 equals to pi over 2. And pi over 2 is also our answer. So we have here 3 solutions. Solution set has smallest angle is pi over 2, followed by 7 pi over 6, and 11 pi over 8. This is our solution set.
Yep.
So which means don't panic if you see different functions. For example, in problem number 70, you have tangent and you have cotangent. If I were you, I would change cotangent to tangent, like 1 over tangent theta. So it will be tangent theta equals to 1 over tangent theta. Multiply both sides by tangent theta, and you will get tangent square theta equals to 1. Take square root from both sides, and you will get tangent theta equals positive or negative 1. Split into 2 equations. One, you will be using +1 version, in other -1 version, and you need to solve both equations. So just try to be creative. Here, you need to perfectly know formulas connecting these trigonometric functions. And right now, I do not have a lot of time, but I have some time. I'm going to show you one of problems how to use your calculator. Please have your calculator in your hands. I'm back on page 206. And one of problems is, for example, problem number 47. And what do we need to do here? We need to solve graphically using our calculator. Tangent theta equals to 5. At the same time, we need to have again that restriction. Theta belongs to 0 to pi. What is the meaning of that? It means theta belongs approximately to what kind of interval? From 0, pi is approximately 3.14. So this is your restriction. This is your restriction if you are going to approximate, because you will be finding your answers in the radians. This is why turn your calculator first, and after that push button which says mod, and check if, and please check if your calculator is in radians or degrees. My calculator is in radians. This is why I'm just pushing second button and more button, and I'm back to the home screen. What I'm going to do, how can I find the angle? Tangent theta is equal to 5. If I'm using a unit trigonometric circle, what do I get? I am getting 5 quite far above of on the tangent line. And let's say this is what you see. You can see I'm doing the same thing. 5 is quite far above that circle because radius is equal to 1. I'm going to connect that with the center of the circle, and I'm getting 2 angles in 1 revolution. But how can I find? I'm going to apply arctangent to both sides. Arctangent of tangent theta equals to arctangent of 5. Tangent minus 1 applied on the top of tangent theta is a composition of two inverse to each other functions. Theta is released. So this what you have at the beginning. And now it will help us to find first angle from the first quadrant. Please enter this into your calculator. Arctangent, so it will be second button and tangent button. Enter 5, close parenthesis and push enter. And it will be approximately 1.37. What to the 2 decimal places? Yes, this is your first answer. This is your first angle, approximately 1.37. Another one, which is in the third quadrant, can I say that it is arctangent, which means theta 1 plus pi, guys?
Yes.
Or pi plus this angle? Enter this exactly as you did in this calculator. Again, it will be arctangent of 5, close parenthesis, plus pi. Pi is on that button which we corner, second and corner, and push enter. Arctangent of 5 plus pi. It is about 4.51, approximately 4.51. Is it in our interval? Yes, it is in our interval. And I do not have other values anymore. So I solved this. You can see it is much easier to use your calculators. You just need to know which buttons to how to enter these expressions. I'm going to again carefully see how Zoom is doing recording of that lecture, and as soon as it is done, I will try to send you the link. Can I end my session today?
Yes.
Yeah.
Okay, guys, have a nice, beautiful day, and I will try to send you the link as soon as possible. Okay,
Bye.
bye, guys, bye.